Hello and welcome to another video. In our previous videos, we were looking at indefinite integrals, meaning integrals that do not have an upper and lower bound. However, in today's video and the next videos, we're going to be looking at definite integrals, which are integrals that do have upper and lower bounds. This means that we have our typical integral here, integral of f of x dx, but we have a lower, and an upper ground, where our upper ground is always bigger than our lower ground. And this is to solve for, in this case, using Barrow's theorem, the area under one curve. So if we have a function like the following, here we have our x-axis, and here we have our y-axis, or point 0, and we have this function, for example, and we want to find the area under a curve between points A and B, B being the larger one, we want to find this. And using Barrow's theorem, we can. The following formula is quite simple. It is simply A, B, this is our f of x d of x equal to, and this is going to give us, since it's a definite integral, f of b minus f of a. This capital letter F, these capital letter F, basically mean the derivative of x. So this is going to be the derivative of x on point B, and this is going to be the derivative of f of x on point A. And by just using this simple formula, we will find the area under the curve of this function. So let's practice with a very simple example. Let's say our f of x is x squared, which we know has the following shape. It's a parabola crossing point 0, 0. So we want to find between the lower bound of 1, so a equals to 1, and the upper bound of 3. So we want to find basically this area from 1 and 3. And we just apply our formula, x squared, the integral of x squared, upper bound 3, lower bound 1, dx. And now we solve our integral first. This is going to be simple. Remember that x to the power of n, an integral of x to the power of n, is equal to x to the power of n plus 1 divided by n plus 1. So this is going to be x to the power of 2 plus 1 divided by 2 plus 1. And this is going to be evaluated in 3 and 1. This is going to be x to the power of 3 over 3. And this is going to be evaluated in 3 and 1. So we're going to get here 3 to the power of 3 divided by 3 minus, following our formula, 1 to the power of 3 over 3. And that is going to be equal to 3 to the power of 3 is basically 3 times 3 times 3. We can cancel one of these and say this is a 2 and cancel this one. 3 to the power of 2 is 9. 9 minus 1 to the power of 3 remains a 1. 9 minus 1 third. And this is going to be equal to 9 times 3 is 27. 27 minus 1 is 26 thirds. And then obviously our units squared. The area under x squared between points 1 and 3 is 26 thirds units squared. And that will be all for today. This is how you find the area under a curve using Barrow's theorem and definite integrals. Thank you for watching, and check out my next video in which I'll be continuing to practice with problems of Barrow's theorem and finding the area under a curve.